Assalamualaikum and greeting to the panelists. My name is Detector and I'm going to present my final year project. The title is Analysis of Chlorpyrifos in Cauliflower using a quick, easy, cheap, effective, rugged and safe coupled with gas chromatograph-electron capture detector. Without any further, let's move on into our introduction. Nowadays, pesticides must be used in a modern agriculture to prevent pests that can harm a plant growth. Chlorpyrifos is an organophosphate insecticide commonly used in a home and on a farm. Due to a complexity of a sample metric and trace level, pesticide analysis in food metric is extremely difficult. Several studies are currently being conducted using QueChERS. The QueChERS method outperforms a traditional method. Previously, the results showed that GCECD are the better detector for measuring a chlorpyrifos. Ladies and gentlemen, eventually we proceed to the problem statement. First of all, chlorpyrifos is a trace level substance. As a result, pesticide analysis is extremely difficult and a new modern method must be introduced. In this study, QueChERS was used as extraction method with the utilization of GCECD for analysis of chlorpyrifos in a cauliflower. This proposed method provides an effective cleanup procedure, reducing a total analysis time and chemical required. Meanwhile, the significant study is because of sample preparation technique use a basic laboratory equipment, making it relatively inexpensive compared to traditional method. As a result, a sample preparation technique that is widely used in analytical chemistry, particularly in the field of food analysis. The following are the objectives of my research. First is to optimize the QueChERS by varying the quantity of primary secondary amine PSA, and secondly to determine the concentration of chlorpyrifos in cauliflower of a different source using QueChERS and GCECD. Next slide is literature review. Figure 1 shows a chlorpyrifos, a broad spectrum organophosphorus insecticide used worldwide to control agriculture and structural pests as well as mosquito. The toxic effect of cholinergic inhibitor is caused by a disruption in nervous system function, which causes muscle twisting and paralysis. There are currently several studies of chlorpyrifos analysis in various samples, for example, LLE, SPE, SPME, and MSPT. But all of these methods have more disadvantages than advantages. As a result, QueChERS, a modern approach, was introduced. This method gained a popularity due to its microscale extraction procedure, which is simpler, takes less time, employ an organic solvent as opposed to all previous methods. Meanwhile, GCECD has been selected as the analysis instrument. This method is more efficient, uses fewer chemicals, and more selective than the previous method. This method is useful to determine a chlorinated compound like the target analyte. Following that, we will discuss the methodology of this study. The sample collection and the sample preparation of fresh cauliflower was purchased from a variety of local markets. Using a knife and a chopping board, the sample was homogenized. The sample has been cut into a small size. The extraction of chlorpyrifos using QueChERS technique start with, firstly, 2 gram homogenized cauliflowers was transferred into 50 ml centrifuge tube, and 25 ml of ACN were added into a solution. The solution was shaken for 1 minute. Then 2 gram NGSO4 and 0.5 gram NaCl added and centrifuged for 5 minutes. After centrifuge, about 25 ml liquid of supernatant was transferred to the 50 ml centrifuge tube containing 150 mg MgSO4 and 20 mg PSA and vortex for 1 minute. Then the solution was centrifuged for 10 minutes. After centrifuge, about 20 ml solution was transferred to the rotary evaporator to eliminate the ACN. Lastly, 1 ml sample ready to transfer to vial for GC analysis. Different amount of PSA, 15 mg, 25 mg and 30 mg were used in a study to determine the optimal amount for efficient extraction in a cauliflower. Next, result and discussion. Working solution were prepared between 0.5 to 10 ppm. A calibration curve picks areas against analyte concentration was plotted as shown in figure 4.1. The graph shown and a good linearity was obtained for standard chlorpyrifos with a correlation coefficient 0.988. This standard sample can be used to determine which peak contain chlorpyrifos. Figure 4.2 shows the chromatogram of standard chlorpyrifos at concentration of 4 ppm analyzed by GCECD. Chlorpyrifos was eluted at a retention time of 6.576 minutes. After done with the calibration curve, we proceed to the determination of blank sample. The Chlorpyrifos residue in this sample was extracted using 30 mg concentration of PSA. The results show no trace amount of Chlorpyrifos detected in this sample. Figure 4.3 shows the chromatogram of blank sample extracted using QueChERS. Next, we move to the optimization. It's done by modifying the amount of primary secondary amine used. In QueChERS, PSA was performed as a cleanup sorbent to remove interfering compound from a sample matrix. Thus, the amount of PSA is crucial and need to be optimized. In order to evaluate the efficiency of QueChERS technique, a recovery study was conducted. The percent recovery obtained was calculated using the following formula. The acceptable recovery for spike sample must be at least 18 or above. The figure shows the percent recovery obtained. The highest recovery of Chlorpyrifos is 84% with the lowest RSD by using a 30 mg of PSA. Below shows the chromatogram obtained with a different amount of PSA. Subsequently, we move to the second objective, which is a determination of concentration of Chlorpyrifos in a cauliflower of different sources using QueChERS and GCECD to quantify the concentration of Chlorpyrifos by comparing the peak area of height to extended calibration curve. The results obtained were compared and analyzed to determine if there is significant difference in Chlorpyrifos concentration among the cauliflower sample. From the table 4.2, sample E have the highest concentration of Chlorpyrifos, followed by sample A and C respectively. Meanwhile, sample B and D was not detected. Furthermore, is determination of LOD and LOQ. The instrumental LOD was determined by decreasing the amount concentration of Chlorpyrifos injected into GC until there is no Chlorpyrifos appear in chromatogram. The LOQ can be determined by signal to noise ratio. The LOD and LOQ were 0.006 and 0.02 ppm respectively. In conclusion, the optimization of QueChERS technique and determination of Chlorpyrifos in a cauliflower sample using the QueChERS method and GCECD was successfully achieved. The result revealed that the optimized PSA has a better percentage of recovery, which is using a 30 mg of PSA. By using the QueChERS coupled with the GCECD, the Chlorpyrifos concentration can be determined from a different source of local market at the Shah Alam. Sample E have a highest concentration of Chlorpyrifos, which is 297.45, followed by sample A and C 292.25 and 273.08 respectively. Meanwhile, for sample B and D, there is no Chlorpyrifos detected. To improve the extraction efficiency and overall performance of QueChERS technique for Chlorpyrifos determination, there are recommendations for sample preparation. First is increase the extraction time by extending the shaking time during extraction. Second, sonication can be considered during the extraction step to enhance the extraction efficiency. Meanwhile, the automatic adjustment of retention time program can be added to optimize the adjust retention time analyzed during analysis. Meanwhile, for the sample has a high water content, consider using anhydrous sodium sulfate to remove the excess moisture before extraction. Next is a primary secondary amine can be replaced with a fluorosil. It may improve a cleanup efficiency and more cheaper than PSA. This is the complete list of reference I used to create this video. Thank you.